At 8:19 p.m. on July 17, 1996, a Boeing 747 lifted off from JFK Airport, just another transatlantic flight heading toward Paris. 229 passengers, 18 crew members, a routine trip. Nothing unusual, nothing alarming. But at 8:31 p.m., only 12 minutes after takeoff, the night sky off Long Island suddenly became brighter than the sunset it had just replaced. Witnesses saw a streak of light, then a massive, expanding fireball. Air traffic controllers watched their radar screens as TWA Flight 800 simply vanished. What followed was one of the most controversial, painstaking, and emotionally charged aviation investigations in modern history. Tonight, we go deep into the timeline, the theories, the science, and the reforms that changed aviation forever. Chapter 1: The Flight That Never Reached Paris. TWA Flight 800 was operated by a Boeing 747-131, a reliable giant with millions of safe flight hours behind it. On this particular evening, the aircraft was slightly delayed. Passengers were already settled, families waved goodbye, crew prepared a long transatlantic service. Among them were students on a school trip, couples on vacation, business travelers, families returning home, and crew members with thousands of hours of experience. Nothing hinted at danger.
At 8:19 p.m., Captain Ralph Kevorkian advanced the throttles. The jumbo jet lifted gracefully into the warm summer sky. The climb was smooth, the weather was calm, and inside the cockpit, the atmosphere was routine, a normal departure. Chapter 2: The Final Minutes. At 8:30 p.m., the aircraft leveled off near 13,700 feet. The crew checked in with air traffic control. Everything seemed perfect. 1 minute later, everything changed. Radar showed the aircraft suddenly break into multiple pieces. A bright flare appeared in the sky, visible from beaches and boats up to 40 kilometers away. Witnesses described the same sequence: a streak of light, an explosion, a massive fireball, and debris falling like raining sparks into the Atlantic. What happened in that 1 minute became the subject of 4 years, hundreds of experts, and the longest, most expensive NTSB investigation at its time. Chapter 3: The Ocean of Evidence. Within hours, the U.S. Coast Guard launched one of the largest underwater recovery operations in aviation history. Ships, divers, sonar equipment, even robotic submersibles. The Atlantic waters were calm, but the debris field stretched for miles. Small fragments floated on the surface, including seat cushions, wiring, and luggage. Larger parts sank to depths reaching 120 feet. The mission was clear: recover everything, understand everything, leave no doubt.
And so they did. Over the next months, investigators painstakingly recovered 95% of the aircraft, an unprecedented reconstruction effort. Inside a giant hangar in Calverton, New York, piece by piece, panel by panel, the Boeing 747 was rebuilt like a jigsaw puzzle from the seafloor. This was not just engineering. This was archaeology, aircraft forensics at its most extreme. And one detail stood out: the explosion originated near the center wing fuel tank. But why? Chapter 4: Theories That Shook the Nation. Before the investigation even reached its first month, the public was already deep into speculation. The first theory suggested a missile strike. Dozens of eyewitnesses reported seeing a streak moving upward toward the aircraft before the explosion. The possibility of a missile, accidental or intentional, became a national headline. Some believed it was a terrorist attack. Others suggested a U.S. Navy training accident. Conspiracy theories grew faster than facts could be confirmed. The second theory pointed to a bomb on board. The mid-air breakup, the fireball, and the sudden radar disappearance led many to compare the event to previous bombings like Pan Am 103 over Lockerbie. Security screening in 1996 was not what it is today. Checked luggage didn't always travel with its passenger. Bag scans were limited. The third theory suggested a mechanical failure. Some aviation experts immediately pointed toward the fuel tank. Boeing 747 center wing tanks had already raised concerns for volatile fuel vapors. But until the investigation progressed, nothing was certain. And the pressure on investigators was intense. The world wanted answers. Families demanded truth. News channels wanted headlines. But the ocean keeps its clues deep, and it would take time before they surfaced.
Chapter 5. Inside the heart of the explosion. Months into the investigation, NTSB engineers noticed something unusual. The center wing fuel tank, located between the cabin and cargo hold, contained only a small amount of fuel, just a few inches at the bottom. On a hot summer day at JFK, surrounded by ground operations and air conditioning systems running, the tank heated up. Fuel vapors expanded. The mixture became more flammable. But a tank filled with vapors still shouldn't explode on its own. It needed an ignition source. And investigators found one. A faulty electrical wire in the fuel quantity indication system. A tiny spark, invisible, unexpected, but powerful enough to ignite the fuel vapor. When it did, the explosion blew the tank apart, tore the forward fuselage off the aircraft, and sent the remaining structure spiraling downward. This matched the debris pattern, the radar breakup, and the cockpit's sudden silence. But there was still a problem. What about the streak of light witnesses saw? Chapter 6. Eyewitnesses, Illusions, and the Sky at Dusk. The NTSB interviewed 258 witnesses. Many described an object rising before the explosion. But the context of these sightings mattered. It was dusk, a bright setting sun, reflections on the ocean, flaming debris shooting upward after the initial failure.
Some witnesses saw the aircraft's nose section, still burning, arc upward as it separated, creating the illusion of an incoming streak. Others saw the initial explosion before the sound reached them, causing timing confusion. Human perception at long distances is complicated, especially when observing unexpected, violent events. This didn't mean eyewitnesses were wrong, but it meant their perspectives needed careful analysis. And the forensic evidence, including wiring damage, fuel vapor chemistry, and structural fractures, all pointed toward an internal explosion, not an external one. By the third year, engineers, chemists, metallurgists, and reconstruction experts agreed the fuel tank explosion was the initiating event. But this tragedy wouldn't be in vain, because what investigators discovered next would change aviation safety around the world. Chapter 7. The Reconstruction of a Disaster. Inside the Calverton hangar, investigators built what many called the world's largest 3D puzzle. Panel by panel, frame by frame, they reconstructed the Boeing 747's forward fuselage on a huge steel grid. This wasn't for show, it was for answers. As the structure took shape, patterns emerged. Outward blown metal around the center wing tank. Fracture lines radiating from the tank's walls. Soot patterns showing where fire traveled, and the unmistakable signature of a sudden high-pressure explosion inside the tank.
There were no penetrating holes from outside, no shrapnel trails, no missile fragments, no explosive residue typical of a bomb. What they found instead was a silent killer hiding inside the aircraft, a volatile fuel vapor explosion caused by a tiny spark from aging wiring. That spark changed aviation forever. Chapter 8. The Science of the Explosion. Fuel tanks don't explode easily, not even with heat, but the TW-800's center wing tank had a perfect storm inside it. First, there was the summer heat. The aircraft sat on the ground for hours in hot weather. The sun baked the wings. Air conditioning compressors under the cabin generated intense heat directly under the tank. The temperature inside the tank reached levels high enough to vaporize the remaining fuel. Second, there was a low fuel level. Only a few inches of fuel were inside. More air plus more vapor equals a more explosive mixture. Third, there was aging electrical wiring. The fuel quantity indicating system used wiring that had degraded over the years. Microscopic cracks in the insulation allowed voltage to jump. It didn't need to be a big spark, just a tiny arc, enough to light the fuel vapor. Fourth, there was the chain reaction. The explosion blew apart the center of the aircraft. The nose section detached instantly. The midsection continued forward briefly before aerodynamics tore it apart. The wings, engines, and tail separated as they descended. This sequence perfectly matched radar data, witness angles, and the debris field. And finally, the truth became undeniable.
Chapter 9. The Final Minutes Recreated. Just before 8:31 p.m., the cockpit crew was discussing routine operations. There were no warnings, no alarms, no system failures visible. Then, in a fraction of a second, the explosion erupted beneath the cabin floor. The flight data recorder stopped instantly. The cockpit separated. The forward fuselage fell almost vertically, crashing into the ocean within seconds. The rest of the aircraft, still carrying momentum, arced upward briefly, creating the visual streak many described before breaking apart in midair. Debris rained into the Atlantic in two main fields, exactly matching this reconstruction. No human on board ever had a chance to react. The event was instantaneous, silent, catastrophic. And yet the world demanded to know why it happened and how to stop it from ever happening again. Chapter 10. The Official Findings. After 230,000 pieces of debris, 7 million labor hours, 755 witness interviews, and 4 years of analysis, the National Transportation Safety Board released its final report.
Their conclusion? TWA Flight 800 was destroyed by an explosion in the center wing fuel tank. The ignition source was an electrical short circuit that traveled through the fuel quantity indication system wiring. There was no evidence of a missile or a bomb. But for investigators, this wasn't the end. It was the beginning of something bigger, because finding the cause wasn't enough. They needed to change the system that allowed it to happen. And that system was the world's aviation safety framework. Chapter 11. The reforms that changed flying forever. The tragedy of TWA Flight 800 led to some of the most significant aviation safety reforms of the modern era. New rules on fuel tank safety required airplanes to reduce explosive vapors inside fuel tanks. This led to the development of the nitrogen inerting system, which pumps nitrogen-rich air into tanks to displace oxygen, preventing explosions even if a spark occurs. This system is now standard across modern aircraft. Massive electrical system updates followed. Airlines around the world replaced aging wiring. Insulation standards were rewritten. Voltage protections were strengthened. Maintenance procedures were overhauled. Improved passenger baggage screening was implemented. Although terrorism was ruled out, the incident occurred during a time of global concern. As a result, many airports improved threat detection systems, matching passengers with luggage, and enhancing explosive scanning. Enhanced witness analysis training was developed. Investigators created new protocols for interpreting visual sightings during aircraft accidents, reducing misinterpretations in future cases. Research into fuel volatility expanded. Engineers conducted new tests to understand how fuel vapors behave under heat, leading to safer tank designs in newer aircraft.
All of these lives saved, all these disasters prevented, came from the lessons written in the final moments of Flight 800. Chapter 12. Why Flight 800 still matters today. More than 2 decades later, Flight 800 remains one of the most studied aviation events in history. It wasn't just a crash. It was a wake-up call. A reminder that in aviation, even the smallest flaws can have enormous consequences. A single wire, a tiny spark, a nearly empty tank, and 229 souls lost. But aviation today is safer because of what was learned. Every modern flight you take is protected by systems developed in the aftermath of this tragedy. Fuel tanks are safer, aircraft wiring is safer, investigations are smarter, and public understanding of aviation grew deeper. This is why Flight 800 continues to be discussed, not as a mystery, but as a crucial turning point in aviation safety. When the sky turned into a fireball that evening in 1996, the world lost far more than a plane. Families lost loved ones, communities lost friends, and aviation lost a sense of invincibility. But in their memory, the aviation world built something lasting, a safer future.
Today, when you board a flight, when you look out the window at the wings shimmering in the sunlight, just know that the lessons of Flight 800 are flying with you, protecting you, guiding every engineer, every pilot, every aircraft mechanic. Tragedies shape progress, and the legacy of TWA Flight 800 lives on in every safe landing across the world. If you found this deep dive into aviation history fascinating, make sure to hit that like button. It helps the channel reach more aviation fans, and subscribe for more well-researched stories from the remarkable world of flight, disasters, mysteries, and breakthroughs. Tell me in the comments which aviation story we should explore next. Thanks for watching, and until the next flight, stay curious, stay informed, and stay safe.